What is electrical current? Hey guys, I'm Zach, and in this video we'll go over all the essentials of electric current and everything you need to know to dive further into electrical analysis. In the most simple terms, electric current is the amount of charge that flows through a wire over a given period of time. But what is charge, and how exactly does it flow? Well, electric charge is a fundamental property of matter that causes it to experience a force when placed inside an electromagnetic field. We know that in an atom there are electron clouds that orbit the centralized nucleus, which is made up of protons and neutrons. We also know that some materials have loosely bonded electrons, called free or valence electrons, that can be removed or added with very little effort. Materials that allow this process to occur easily are known as conductors, and materials that resist this change are known as insulators. Good conductors generate a flow of electric charge easily due to the large amount of free electrons drifting throughout the material. This electron drifting is completely random until an external force is applied. When we introduce a force external to the conductor, we generate a potential difference in charge between the two ends of the material. These two ends are known as the anode and the cathode. This change in electric potential forces negative electrons to flow through the conducting material from the anode to the cathode, and we depict the direction of flow using the charge polarities positive and negative. In the industry, we use conventional current flow instead of electron flow. This means that we examine current flow from the positive to negative terminal of a system, despite electron flow actually going the opposite way. There are two mathematical expressions used extensively in electrical analysis to determine the value of electrical current in a circuit. The first being current equal to charge divided by time. The current is measured in amperes, or amps for short, and the charge and time are measured in coulombs and seconds respectively. This equation mathematically displays our definition of current earlier as the amount of charge over a given period of time. The other equation is known as Ohm's law and equates voltage to current multiplied by resistance. When rearranged, we get current equal to voltage divided by resistance, where voltage is measured in volts and resistance in ohms. What this equation tells us is that the current flow in a circuit is dependent on the voltage and resistance through that circuit, and if we have no voltage, current cannot flow, hence leaving us with an open circuit. The most common analogy for visualizing current flow is the flow of water through a river. If we imagine the river is a length of wire and the water flowing through the river is the electrons flowing through the wire, we denote the current as the amount of water that flows through the river in a measured period of time. Hence, the current through a wire represents the amount of charge that flows through the wire over a measured amount of time. And that is all you need to know about electrical current to dive deeper into electrical analysis.